Hello. Okay, mine is working. Is yours working? What?
Yeah, it's on.
Okay.
You want to start?
Yeah, no, you're gonna.
Does this mic work? It does. All right.
Hi guys, we're gonna start in 3, 2, 1.
Welcome. Thanks for coming, everybody. My name's Brian.
My name is Portia.
I'm here with Portia on behalf of the Career Services team, Jocelyn and Julia, wherever she went. And we're here to talk about technical interview, talk a little bit about ourselves first, and then we'll go into some of the topics that we're going to talk about today and go through some sample questions. And I'll hand it over to Portia to start with to introduce herself.
Okay, so my name is Portia. I am originally from Hong Kong, and I came to US for college, went to NYU for economics and math. Then I came to Berkeley for IOR. I currently work at Customer Marketing Group, so whoever has been to the last career fair would have seen my booth and maybe have met me. So a little bit about my interests. Recently I started yoga. I tried to do that move last Monday, and lasted about 3 seconds. And then my body ached right now. And then my other hobby is that I love to cook. I cook every single night, and I've just started making juice. Yeah, green juice, healthy juice. So Brian, something about yourself?
Cool. So I'm originally from the Northeast US, from Vermont. I went to Cornell for undergrad and then got a job working for the Blodgett Oven Company. It's a company that makes commercial restaurant ovens out on the East Coast. And did that for a few years and then decided I wanted to get into the auto industry, and so came out here to UC Berkeley for a master's degree in mechanical engineering, and then following that got a job with Tesla. When I'm not working on cars, I like to be outside. You can see I've got some pictures from hiking and skiing. I like to sail and play board games on the weekends, and then every now and then I make lemon bars. And after about a year of it, I've perfected the recipe. So it's a good time. What we're here to talk about, I mentioned it a little bit at the beginning, and I'll go over it in a little more detail here. We want to start with what to expect in a technical interview. So going into it, being able to prepare yourself for it, and knowing what types of questions get asked. Then we each have a sample question we're going to run through and talk to you guys about the sorts of answers that we're looking for, and if you can't answer the question fully, what kind of direction we're hoping that you go in to give us the best idea of your capabilities. We want to talk a little bit about what you can do to prepare for technical interviews, the sort of resources that exist both on the internet and here at school that you can use to learn more about the subjects that are hard to find in academia. And then at the end, we'll each share a story about sort of how we found our own jobs and give you guys tips and tricks for the job search. And then we've got some time for questions at the end. So I'll start with technical interviews for mechanical engineering. I'm a mechanical engineer. Portia's IUR, so she'll go over her side of things. But for mechanical interviews, we generally break it down into a bunch of different topics, and we usually won't ask one interview candidate all of these topics, but any one of them is likely to show up and in two forms. In some types of mechanical interviews, they'll actually give you a test, and it's the sort of thing that you take at home and then submit back to the company. And in some cases, you'll just walk into an interview, and the person will start drawing on the whiteboard and set up a sample question and ask you to walk through solving it. So the types of stuff you see are mechanics, statics and dynamics, usually pretty simple stuff like beam bending or free body diagrams. That stuff should be pretty familiar to you guys while you're still in school. Manufacturing questions usually come up. That's something that we like to go after because it's something that's hard to find in schools, is that they often don't teach detailed classes about manufacturing processes, so things like injection molding or die casting or extruding or stamping, and the sort of associated material properties of those processes and what sort of materials and what sort of shapes you can make from them. It's something we often like to ask about because that can really set a candidate apart if they already know something about certain manufacturing processes. One of my colleagues' favorite question is how to put things together, because that's also something that people don't think about or don't talk about much. And the assembly process, like, okay, you can design this object in CAD, sure, but then what are the steps that you're going to take to put it together? How do you set up a manufacturing line to put that together? What parts do you make sub-assemblies? What are the human operations? What are the robot operations? Sort of breaking it down and thinking through how something gets manufactured, and specifically looking at fasteners. There's a million different ways to attach two pieces together, and which one you use depends on a lot of different factors, and that's something that has a lot of detail to it that you can bring out, and you can see if someone really understands the depth of manufacturing and assembly, or if it's something that they've only touched upon. For mechanical, sometimes we'll ask electrical questions, especially because these days electrical and mechanical are so intertwined, but it's usually very simple stuff, just very basic, either heat generation or like how big does this wire need to be, types of questions. Very simple, like resistor, capacitor, circuit diagrams. It's something that I would recommend that you are familiar with, but I wouldn't worry about going too deep into the electrical side. And then another thing we often will like to bring up is drawings, specifically geometric dimensioning and tolerancing, GD&T, which is something a lot of students don't get exposure to until they're out working for a company in the industry. And that's something that, again, can set apart like an outstanding candidate versus a great candidate, is whether or not they have experience with drawings and know if you were to send this to a manufacturer, what dimensions would you put on it, what datums would you use, and then how would you set it up so that you relay the information you want to relay without overcrowding the drawing with every dimension that exists. And then the last two topics that show up, I think, less often in my experience is thermals and fluids. And I think some of that depends on what company you're working for. So if you were interviewing with like an HVAC company, for example, they would be more likely to ask you these sorts of questions because it follows directly from their line of work. So that's mechanical engineering. That's an overview. I have a couple sample questions I'll go into, but I want to hand it over to Portia first and let her give an overview of what to expect in IEOR. Welcome. Thanks for coming in. Grab a seat.
Front row, front row. Come on, here. Right here. Three empty seats. Okay. So for those who are interested in getting a position in data as a data analyst, so I'm going to be talking about that. So I would like to talk to you first about the process of data analysis. I mean, this looks a little bit trivial, like everybody knows about it if you have done a research, and then I will pinpoint what are the areas where you will be tested on in a technical interview. So I would like you to look at this flow and from a tech firm perspective plus a consulting firm perspective. So for a tech firm, so personally, I've not worked for a tech firm before, but I've interviewed with a couple. They would use this information. They would do the data gathering and use this information internally to help their own product to do better. As for a consulting firm, usually the data are given by the client or a third source, and then they will use these data to help their clients make better decisions. And for my job in CMG, I am a data analyst that I will analyze the data that's being given from the client, and I will recommend them the best strategy where they can solve their problems. So first of all, data gathering. I'm going to stress a couple of times on this A/B testing thing, because if you go into an interview with a tech firm and you do not know A/B testing, you're out right away. So A/B test is a must. And so how do people gather data? For tech firms, they usually do A/B tests. There's a control group, and then there's a test group. So you can search it up on Wikipedia. After you've gathered all the raw data, there will be a process where you merge those raw data together, clean it up, and make sure that somebody, which is us, data analysts, will be able to extract it. So organizing and structuring the database is probably not a data analyst job, but more of a back-end engineer, architect type of job. However, the knowledge to pull the data is very important. Most of the time, companies will test you on how to pull the data,
and they will ask you to use SQL to do it. Mainly because it is the easiest, the most colloquial language where you'll be able to use in an interview. And all of the phrases in SQL is pretty much colloquial. And if a firm asks you to use SQL, do not use anything else. You're out right away, almost. Unless they say it's flexible. So after you pull the data, there's a process where you have to analyze it. Now, most of the time, as a data analyst, you'll be given a question. So interviewers would like you to know if you'll be able to break that question down. For me, when I work with a client, they always ask really broad questions because they're not in our position. So you have to ask for more information to break the question down so that you'll be able to answer the question specifically. So that's the first step, break it down. After that, you have to define useful metrics. So let's say a client asks you, why did our profit go down this year? Then what are some of the obvious useful metrics? Revenue and cost, right? So you have to define these metrics. And after that, you have to compute and understand the result, whether you compute it using R or Python, or you can compute it straight from using your SQL code when you pull the data. That works. And understanding the result is mainly like, is the result positive or negative? And regarding this point, one thing is very important. When you go into the interview, you're not expected to know the industry extremely well. However, when you make decisions regarding the result is good or bad, you want to use relative terms. Usually, interviewers are going to give you some more assumptions or like some more data points for you to make relative decisions based on if a result is good or not. I'll do an example later, so don't worry if you're confused. Displaying the results. I'm sure you hear a lot from like Alex classes or something like that, like do not use a pie chart kind of thing. Is it better to display the result with a table, or is it better to display a result with a bar chart or a line chart? That's like up to you to back up your answer. So conduct statistical test. Sometimes, I put it at the last because sometimes you need a statistical test, sometimes you don't to do the analysis. So now I've gone through the whole process, what to expect in an interview. Basically, I already said it. You have to break it down, understand the question, define the useful metrics, retrieve the data, and compute the metrics, analyze the results, like I said, relative terms, and then you have to display the results so that your client or your manager, your boss, will be able to understand. A lot of the times, your clients are not like strong in math or like strong in statistics, so you got to make sure that they will be able to understand what you're talking about. So I'm gonna go off with an example, and then after I finish my example, Brian will do his example. So the ME people can take a rest, I guess. So let's say there is a digital coupon app. Let's say there is a retailer, let's say Whole Foods. Whole Foods used to use paper coupons where consumers like us, customers like us, will have to go flip through a newspaper, cut it, and then bring it to Whole Foods and then scan it to redeem the coupon. Then that's the whole process of redeeming a coupon. However, technology has advanced. So there's a digital coupon app that you can download on your phone, and you bring it to the store, flip it through, and find whatever coupon that suits your purchase, scan it right away. Now, let's say you work in a team that is that monitor the performance of this app, and your manager asks you, "Is this a successful app?" Then what are you going to do? Now, this is the point. If an interviewer asks you such a broad question, this is hints to test if you can break it down. And what is a term that's very broad here? Successful, obviously, right? So what are you going to ask? You have to define your own metrics. You can't ask your boss to define it. So you ask, what do you mean by successful? You're probably right, yes. So let's say, and so when you answer a question like this, like, what do you mean by successful? Tell the interviewer that you have thoughts in your mind. Is it that it makes more profit? Is it that it makes more revenue? Or is it that it has more users, right? So bring it out and make sure your interviewer knows that you're using your brain. And the interviewer says, oh, it means that, like we determine success by the number of active users, okay? And we're given this data set that we can see. And in an interview, the interviewer will give you a data set without numbers, but the metrics. So let's say we have a user data set. There's a user ID, timestamp, and status. So the data set will look like user ID is 001. Timestamp is today at 11:30. Status, you log in, okay? User ID, second line, user ID 001, timestamp 11:35, scan is the status. Just so on and so forth. That is a database that you get. Now, you have to find the number of active users. Don't get distracted by the database right away. Is that question narrow enough for you to answer with the database? Someone? Awesome. Yes. That's what you want to ask. How do you define active users? So let's say the interviewer says, oh, we usually define active users by like the number of, okay, so let's say for those people who have scanned twice in the last 3 months are considered as active users. So now your questions would have become, find the number of users who have scanned in the past 3 months. Sorry, the twice, I just added it. I didn't prepare for that. So the number of active users scanned in the past 3 months. Now, you can go on to your code. However, do not start going like, oh, select this, find from, like go into your SQL code right away. You have to practice thinking out loud and let your interviewer know what you're thinking. Let me try it once. Let's say, from this question, we know that there's 2 constraints. One is a month, and the second one is the status, which is going to be scanned. And we want to make sure that these 2 constraints are taken into account. And what exactly we're going to find, we want to find the number of users distinctively. So we want to count the distinct users that match the following the 2 condition. Okay, so this is a brainstorming, a qualitative answer to what the interviewer wants. Then you can go on to your SQL code. So there are many ways to do it. This is only one way to do it. You don't have to know the timestamp on top of your head because you're not Google, but you can just say it out loud. I got it from Google. Anyway, so when you do something like this, when you go into an interview, when you are expecting a technical interview, always bring paper and pen with you, because when you say like, oh, select, count, distinct, you don't want to mess that up in your head. So always bring a paper and pen, write it down, write the question down, and write your answer down. Because after you answer this question, it's very likely, because this one is very simple, it's very easy. They want to start off to know that if you can break the question down, something like that, and it start off easy. However, after this question, you're often going to ask, you're going to often get a question that's way harder, which includes like inner join, outer join, as well as how do you make this faster? How do you make it shorter? Or they're going to ask you, give you a new database and see if you can, if you're going to get distracted, maybe you only need the first database, but not the second, right? So there are a lot of tricky parts that will go after this, but if you have gone to this point, you've done well. So after this, after you have pulled and extracted data, it's time to analyze results, right? So like I said before, interviewer are usually going to give you more information. Let's say for this distinct, so count the distinct users. Let's say you found 500. The interviewer is going to give you these numbers, okay? The interviewer says, let's say you found 500 here. And then we've always known that there are 5,000 active shoppers in the shop, in Whole Foods. And previously, when we were having paper coupons, there were 1% active users for those. And how are you going to conclude if this is a successful app or not? Someone willing to try? So we have 500 active users we found, 5,000 active shoppers, and previously we have 1% for the paper coupon. What's 500 divided by 5,000? Yeah, so somebody said 10%. Okay, so there's 10% active users for this app, and versus 1% active users for the paper coupons. And what's your conclusion? Is it a positive or a negative? So remember, the question was, is it a successful app? How would you define it then? How would you conclude? Someone? We have 10% and 1%. Okay, so you're going to say there's 10% active users for this app, where compared to 1% for the paper coupons. The app is relatively more successful than the paper coupons based on our definition of success. Be very careful with this, and make sure you know that you're making the conclusion from the information that you're given and in a relative term, because there are a lot of other metrics that can be involved in this definition of success, where right now you're only taking into account one. So we want to make sure that the interviewer knows that you are being analytical. And then after that, there's going to be like a couple of Q&A, or they might ask you, what is the problem with the analysis that you did just now? So do not panic when interviewer asks you this, because they're not saying that you did anything wrong. It's just saying that you have to be analytical in the process that you just did. And you can point out like, oh, there are other metrics that we can consider, and we cannot just draw a conclusion with like one metric and something like this. So this is my example. If you have any questions regarding this example, please write it down so that you can ask in the Q&A. And I'm going to pass it on to Brian for his example.
Thanks, Portia. So I want to dig into manufacturing questions. I'm going to stay away from the more academic questions like mechanics and fluids and thermal, because I think that's something that students are more familiar with. And I want to get into the questions of how things are made, and then why it was made that way, and what are other ways it could be made. And these are questions that what manufacturers are interested in, or what companies are interested in seeing, is that you don't live in a world that's only CAD, but you actually understand how to move something from CAD to real life, besides, we'll 3D print it, which it could be the answer to everything, but 3D printing is slow and has material properties constraints and has material constraints. So if you want to make something strong, or you want to make something out of stainless steel or titanium, you'll get better material properties from a different material process than if you 3D printed it. So I've got 4 examples here of common-ish items, and I just want to sort of ask you guys how you think they're made. I'll throw some ideas on the board, and then I want to go over the sort of answers that a company would be interested in seeing. So I'll start with number 1. This is a heat sink. For those of you who aren't familiar with the insides of computers, it's the sort of thing you'd bolt onto a processor or other hot component inside a computer and use it to get heat away from it. So is anybody familiar with how that might be made? Yeah?
Abrasive water jet cutting.
Water jet cut. Absolutely, could be one. What's that? Could be a casting. Yep. Could be an extrusion.
Maybe wire EDM.
Could be wire EDM'd. I'll take one more.
Milled.
Could be milled. Exactly. So these are all the different ways that part could be made, that top left heatsink. And all of these different, and there's probably more, right? It could be 3D printed. It could be a variety of things. And in each of these processes have different pros and cons, have different constraints, and have different capabilities. So for something like water jet cutting, if you were going to water jet cut it, so a water jet cuts with a beam of water that comes out of a nozzle and cuts straight lines straight through a part. So if you were going to water jet cut this, which side would you cut from? From the side that's exposed, right? And you would cut down the length of the fins, is that right? Exactly. So if you're cutting, I'll give a view from the water jet nozzle head. and I'll make fewer fins so I don't have to draw as many. The water jet nozzle would point into the page this way and would cut this out of a solid block of aluminum. And then water jet has some interesting characteristics. As you get further away from the nozzle, the water jet beam spreads apart. So your cut ends up looking from a top. If you're looking at the nozzle this way, this is your water jet nozzle, and you're cutting apart. The cut in the part actually ends up widening as you get away from the beam. So you get a wider cut at the bottom than you get from the top. And that might be okay, but that's something you need to take into consideration with your heatsink design, is you won't have the same profile across the whole heatsink. Your fins will be wider at the end closest to the nozzle and narrower at the far end because the beam will be removing more material. So that's okay. It's just something that you need to have in your mind as you design the part. WaterJet also has a maximum thickness that it can cut, and so your part can't be deeper than that maximum thickness. And the thickness depends on the material, on the WaterJet itself, and I guess it's most of it. And so you have some max thickness, and that determines some of the dimensions of your part. You can't have it deeper than the WaterJet capabilities. And WaterJet also, you can see there's a couple of fins that are removed front and back for screw holes, for mounting holes. And you won't be able to get those features with a WaterJet. The WaterJet's only going to cut the profile out. So you have to come back through after you WaterJet it and get those features, probably with a mill, is the sort of thing you would use for that. So that's one great example you could do. Next, if you were going to cast this, is anybody familiar with castings here? Somewhat? So for a casting, for the rest of you, a casting is two halves of a mold that come together and has the part in it. And so you need to consider a parting line of where that mold will separate. And then all of the surfaces that go into that from that parting line need to have a draft on them. If they're vertical and the mold tries to slide apart, it'll get stuck on the metal and it won't let it actually come apart. So if you were going to cast this, where might you put the parting line?
Just make this with one end of the mold.
One end, right. So the parting line would actually be the bottom of the part, precisely. So I'll draw this again. From the bottom, though, if this is the bottom of the heatsink, if the parting line is the bottom, all your other surfaces need to be drafted away from the top half of the mold. So your walls need to come in like this. Pardon my heatsink. So all of these surfaces, so the top half of the mold, as this half, there's this big mold up here, and when it lifts away, as soon as it lifts the smallest micron, now it has clearance to all the surfaces, and there's no drag on your part. So that's another constraint. Again, this is a perfectly reasonable way to make the part, and it has design implications, and what manufacturers are looking for is that you understand, if I'm going to cast this part, that I understand the different types of features that I need to have on the part. And we're not so worried about the details, like what degree draft you need to have. That's not as important. What's important is you understand, okay, I have two halves of mold that are going to come apart, and those two halves need to have some angled surface away from them so that the part doesn't bind into the mold. One of the nice things about casting is the top of your mold can have any shape you want. It's going to be CNC'd or wire EDM'd from a block of steel. So you can actually get all of those features in one casting. So you wouldn't need any post-machining for this part. You could take it out and it'd be ready to go as is, which saves you a milling step that you would otherwise have if you WaterJet cut the part. The other thing about castings that are nice is you don't have any wasted material within the part that you've removed with WaterJet cutting. WaterJet, we start with a solid block of material and remove all the parts we don't want. So there's this extra waste material that you paid for when you bought the raw block of aluminum, and then you lose that when you WaterJet it away. So casting's more efficient from a material use standpoint, which we like. Moving on to extrusions. Is anybody here familiar with extruding? Yeah? How would you extrude this part? The same as the WaterJet. And does extruding have a limit on the angle of the surfaces?
I don't think.
No, it does not. So you can get your square profile from your extrusion. And for an extrusion, it's do you remember those Play-Doh machines you played with as a kid that had the different shapes in back and you'd push down on it and it squeezed out spaghetti or something? That's extruding. You can do the same thing with aluminum, and it presses out. Similar to water jet, you'll only be able to get the profile, but different from water jet, you'll get a constant profile all the way. So the size of these fins will be constant the full length along the part. Extrusions also typically come out in one long piece, maybe 100, maybe 150 feet long. So you'll get a lot of these in one push of aluminum, and then you'll chop them up with a saw afterwards. Similar to water jet, you don't have the ability with an extrusion to get those screw features you need, so you'll have to come back through and mill them out to get those features. So you have some material removal there. One of the nice things about extruding, though, is it's a very fast process. You can push aluminum out of an extrusion press very quickly, so you're able to make a lot of these parts really fast. And unlike casting, there's no cooling time. It comes out in the solid state. So it's the fastest way to make these is probably to extrude them out of any of these processes here. It's the least material removal, and it's the fastest production rate off of the extrusion die. And that's something else that employers will be interested in you being able to look at all of these different manufacturing technologies, and they'll ask you which one's the best. And you'll say, well, what does best mean? Similar to Portia with her question of, is this app a success? They'll say, which one's the best? And you'll say, well, what does best mean? Does best mean the fastest? Does best mean the cheapest? Does best mean the highest quality? And so maybe they'll say the fastest. We're trying to make hundreds of thousands of these parts every year. And in terms of speed, the fastest is probably extruding them. Followed second, my guess would be casting, I think, especially if you made a casting die can have multiple molds in it. So you could do a multi-mold and get 16 or 20 pieces out of one cast. So this is pretty quick too. Casting also gains speed in that you probably don't have any post-machining, depending on what you need for the bottom surface. So this would be another thing to ask is, what are the surface finished characteristics this part needs to have? There's a possibility that this bottom surface that you're mounting to your processor or whatever needs to be very, very smooth. And if that's the case, you might not be able to get the smoothness you need out of a casting, so you would need to post-machine it flat. Whereas you typically can, out of an extrusion, get the surface finish you need for a heatsink. I'm going to go on to the next one. I'll cover wire EDM and milling briefly. Wire EDM is similar to water jet in that you're removing material, but it's much more precise, and it's typically done on a 5-axis head. So you could get all of these features. You could clamp it from the bottom and wire EDM the whole part and have all your features at once, unlike a water jet, which is a 2-part process. And milling, I think you are all familiar with. You take a CNC mill, and you'd have to drill out each one of these channels individually and then come back through and get the mounting spots second. So excellent job. I think you guys are in great shape for this. What's my time look like? I'm going to do one more because I have time. Silverware. Silverware? Let's do silverware, because silverware is a fun one. It's something that's super common every day. You've all used silverware before. How would you make silverware? Change this to silverware. Forging. That's certainly the most common today. Stamping. Other ideas? You could cast it. Absolutely. Other ideas? You could CNC it. I mean, it's not fast, but right? I mean, you could do it. You could 3D print it. You can keep going down the list forever. It's certainly of interest to know that you understand both the common and high efficiency ways, and you understand there are other ways to do it, like 3D printing, that you could certainly make a set of silverware 3D printed. You could probably get features in your silverware that you couldn't get any other way if you 3D printed it. But obviously it has a lot of speed issues and part quality issues. That's exactly, I think forging and stamping are most common for silverware today. I don't know if anything today is cast, although certainly the more elaborate spoons and forks might be. And then CNC and 3D print is usually only used for prototyping. Forging has some interesting technical, like process capabilities. Does anybody here familiar with forging? not so much. So a forging is similar to a stamping, but it's typically done, stamping is with a flat sheet of material, and forging is done with a block of material. And forging, you want the material almost red hot when you forge it, is pretty typical. You can do cold forging, but hot forging is a lot more common. And one of the things that forging does that's really nice is if you have a mold, I'm going to draw a knife mold. It's kind of hard to show because it's kind of small. But this would be the blade of your mold, the sort of the cross-section of a blade of a knife mold. And you'll start out with a square block of material in there. And you'll get it red hot, and you'll hammer it together with this press. Under tremendous heat and pressure, you hammer it. Typically, it hits it 3 or 4 times to flatten out the material. And what it does is the material actually flows. If you look at sort of the stock shape of the material is like this, and the steel has grains in it. And if you do something like milling or water jet cutting or wire EDM, you're cutting through those grain boundaries, and you're weakening the material because the grains aren't continuous. When you forge it, though, you're not removing any material. You're just compressing it into its new shape. So the material actually flows into this new knife shape, and you get these really nice grain lines, where the grains now of this knife are sort of these long, flat lines all the way across the blade. And it makes for a very, very strong piece of material, which is what you want for a knife. You want something that's thin and flexible, but also very strong and very resistant to fracturing and resistant to bending. And so forging is typically done for knives in silverware because of the strength properties you get from it are unmatched with any of the other processes. It's also done at high temp because you're going to heat treat the knife to get it to the certain hardness so it holds an edge. So that's another reason to forge it hot, is that starts you into your heat treating process, if you're going to heat it up anyways. It has some similar limitations as casting. So when you do a forging, you have these two halves of the die that come together, and the die obviously can't have undercuts in it, or there's certain geometry you can't have because you're trying to flow the material. So you need to have drafts on your surfaces, just like a casting. And you need to make sure that the two halves of your die will come together and come apart, and the piece you're forging won't get stuck in either half because of the geometry you've created. Stamping is very similar to forging, but it's done, instead of starting with a block, you start with a flat sheet. I'm going to erase this. So stamping is most common in production of the spoons and forks, which have a constant material thickness for the most part throughout the material. So you start with a flat sheet, and then your stamping die, in the case of a spoon, has some arch to the handle and some bowl here. And then you have another die on the top that mimics the same arch and has the same sort of bowl. And when they come together, and it can be a three-dimensional shape, so you can get the whole finished spoon out of one stamping. So you put in a blank, flat strip of metal, hit it with your stamping press, out comes the spoon. Typically, with a stamping process, you start with a rectangular strip of material. It comes in on a big coil, and so once you stamp your spoon, sort of the top view looks like this, with some sort of a spoon stuck into it. And so then you have to come by, after you've stamped the form into it, you have to come by with a second die and trim away the edge. So you're just left with the spoon you want. And when you do that, you get a sharp burr on the edge of the material all the way around where it's been trimmed. So then you need to have a third process where you deburr the edge. You take a grinding stone and run it around the whole edge of the part, and then that deburrs it so it's safe for humans to use, so you don't cut yourself on the raw edge. So there's a deburr step. Is the final step. So stamp, trim, deburr. So in a manufacturing interview, what we're looking at is that you have some idea of how something might be made, and then what additional steps those processes necessitate. So if you were doing a casting, you'd also have a burr because you have a parting line on the casting where the two halves of the die come apart, and so you'll still need a deburr step. But if you're CNC cutting something, you probably don't have a deburr step because you can use a very precise tool to trim the edge exactly the way you need to, and you'll have a smooth edge all the way around. in terms of speed, looking again, someone might say, what's the best process? And again, you have to ask, what does best mean? Does best mean fastest? Fastest is probably forging and stamping. Does best mean most complex geometry? Then you're probably looking at CNCing, casting, or 3D printing. You can imagine creating some very elaborate spoon out of a 3D printer that had some, imagine like a wireframe dodecahedron on the head with some suspended jewel inside it. You could do that with the 3D printing. It's very difficult to do with any of the other technologies. And so if you're starting up a boutique silverware line for San Francisco and you want something that's hard to copy, you might look at saying, hey, I can 3D print this because of the additional geometry that I can get. I can create a new segment of the market for very high-end silverware, and I can afford to sell them at very high prices. And then I can deal with the fact that 3D printing is a very slow and time-expensive process. So that's what we're looking for is a basic understanding. Again, I haven't gone into any of the detailed numbers. We don't expect you to understand the actual how big does the press need to be? How many tons is the press? What size? How do you build an injection molding die? We're not getting that detailed, but having a rough idea of the different types of manufacturing processes and some understanding of what you might use and when and what other steps that entails is something that's really powerful for us when you interview. One of the other questions we'll ask is, why was something made this way? And so I can tell you, I have this part and it's CNC machined for production. And the question is, why am I CNC machining it when there's all these other processes that I could use? I could put it on I could extrude it, I could cast it, I could forge it, I can stamp it. But for some reason I tell you I'm CNCing this part. What might the reason be for CNCing something like this that has so many other processes that might be faster and cheaper? Yeah?
I think it's because the accuracy, these kind of things need to come back together, so you need very accuracy about the circles.
Exactly. That's it. You have something else to add? What was that?
You want only one of them.
Or I want only one of them. Exactly. That's a very good point, is that if I do any of the other processes, I'm making an expensive die for it, but I can CNC it from a raw block. And for accuracy, CNC is often more accurate. So those are both very good answers to show that you have an understanding of, even if something's made in a way that might be counterintuitive, each different technology has its own benefits and drawbacks. I'll hand it back to Portia now and talk about how to prepare.
So before I get to how to prepare, I figured there's one slide that I missed. So the interview that I talked about just now is only one type of interview. If you get into a final round with a consulting firm or a tech firm, I really can't speak for financial firms because I didn't have experience, but tech and consulting are most of where my experience came from. The final round will be 5 hours long, and that will be 2 of the interviews. So there are other types of interviews that you have to prepare for. So they are in different types of, it can be in different ways that the people test you. You will be given, so one of the interviews that I went into will be they give me a project, and I have to do it within a week at home, or they will give me a project that I have to do within 30 minutes on site. Then you have to run the regression, you have to look at the coefficients, run whatever scientific statistical analysis you need to run, and then the interviewer will discuss with you, what do you think about this coefficient, what does the p-value mean, and why do you choose to use logarithmic regression instead of linear, things like this. So you have to be prepared, make sure you know how to run regressions or in R or Python, things like that. And another type will be stats and probability. This is scary to me, but maybe not for everyone. I was put into a 1 hour interview just to test on my probability. So it's like a final exam. So probability 101, statistics 101, I strongly recommend you to go through everything. Lastly, I would say it's a case study, but so
the example that I did was like very much like a case study, but there are other types of case studies that you'll be doing. Sometimes interviewer will look into your resume and pick project that you have done and ask you for the database. Then they will ask you some weird questions, things you may have never thought about. Most likely they're going to ask you to do a case with your capstone. So be sure to know things that you have done in your past. And case study could be like, this has never came out, but I did prepare for it. It could be like, how many coins can you fit into this room? Or like, how many ambulance do you think New York City need if there's an earthquake there? Things like that. So all you have to do is just come up with the appropriate assumptions, and you can work your way through it. For practice for the crazy question that I just asked, there are plenty online. If you search like interview with like Goldman Sachs, you'll find a bunch. So how to prepare for these? SQL. For those who have never worked in the industry before, you can go to SQL Zoo or W3 School for SQL exercise. That's where I did all of my exercise in 10 minutes every single day. You'll be better than anybody in the industry. Like, they didn't pay me to say this, okay? Study groups. Okay, so study groups will be like what I did just now. It is very easy to come up with a database or an example. I came up with that one. And you have your smartphone, you have Facebook, you have Google, you have Uber. Just think about whatever database you can come up with, like, with the clicks or with like login, whatever. You can pair up like 3 in the front row. I love you guys. You guys can ask each other questions like what I just did, and then one of the person will have to analyze it and back and forth, and practice thinking out loud in the study group, or when you go through homework questions, just talk to yourself and make sure your train of thought is clear and you don't confuse your interviewer. Know the company you're interviewing with. Okay, so for me, preparing for a tech interview, a data analyst position with a tech firm and a consulting firm is very different. First of all, for tech firms, they would ask you a lot more regarding, like, they care a lot more regarding your skill in coding, as well as your defining the metrics, as well as A/B tests. My second time mentioning A/B tests. If you go into an interview and you don't say A/B tests, you're done. Okay, so I just want to remind you guys this. And for a consulting firm specifically, they want to make sure that you'll be able to explain technical concepts in a way that people without technical background will be able to understand. So that's what I do every single day when I go on site to meet my clients who work in sales and marketing. And I did I did an analysis. I have to explain what I did and why I did this. That's what my boss value a lot. If you are able to explain it clearly. So that's something that you have to practice on your own. How people would test you on this. So I just finished my interview. I just finished interviewing on Wednesday for our internship program, and I interviewed a few MH people, and we would ask you mainly behavioral questions because we want to be able to know if you know yourself well. I asked mostly about projects in your resume and stuff like that, so be sure you know that. When it comes to questions like this, you guys should be like, hell yeah, because it's about your life. You know those things that you've done better than the interviewer. You should be able to wow them. And if you can't do that, you need to go back and study yourself, your resume, I mean. So that is very important. And also we'll ask you questions like, how do you define a p-value? That's a simple thing. What is a normal distribution look like? And in what cases would you use a normal distribution? Just things like this that you seem like, oh, it's very simple, but when you go into an interview and you want to dig into the specific, it might be very difficult for you. So practice, and you can go online and look for Statistics 101 classes to review. So that's one of my suggestions. So after Brian to talk about how to prepare for ME interviews.
So one of the biggest things that I recommend is studying the company. Understand what company you're applying for, what they make, what they do, look into their processes as much as you can, understand where they're falling short, look at the media about the company, see what they're doing well, what they're doing poorly, have ideas about what you think you can contribute to that company and how you see yourself fitting in. If you show up to the interview and they ask you something like, what would you like to do here at blank company? And you're like, oh, I don't know, what's available? It's like, okay, this person doesn't even know what we do, so like, how interested are you if you haven't even looked up this company, if you just saw our name at the career fair and said, okay, sure. So have an idea. As far as manufacturing stuff goes, look through the How Things Work videos are great. You can find almost any video for a manufacturing process online. Ask yourself how you would change the company's product. This is a good thing to do, is understand not just why it's so great, but understand where it's suffering and what can be done to make it better. It shows you're an analytical thinker and shows you have an idea of what you can bring to the company, how you can improve it. Stay fresh on physics. Every now and then a question will come up that's just simple math, and if you can't do that, it's kind of a red flag. It's like, okay, this person doesn't understand like simple static force addition. Like this is probably a bad sign. Even if it's something you've done a while ago, definitely freshen up on it. And then the last thing, and I put this in bold because I think this is really important, and it's something that I did not have when I was interviewing, is build a portfolio. So beyond just a resume and a cover letter that's like, this is what I've done and this is why I want to work for you, having a portfolio of just like screenshots of projects you've done in the past, screenshots or pictures of the projects, really lets someone understand what it is you built. So if I remember when I was at MEng, we had a project that was a NASA exoskeleton robot, and they had so many big words in the title that I was like, I don't know what you're doing. Like, what is this? And like, if they showed you a picture of the robot, it's like, oh, that's really cool. Okay, you made this robot. Nice. So definitely put together a portfolio, just like a bunch of screenshots or a bunch of actual physical pictures if you made it, showing sort of what the projects you've worked on in the past. That can be a big boost to a company that's trying to figure out if you're someone they're interested in or not. Let me go for this. So I want to talk a little bit about how we each found our jobs, where to look. It certainly started with career services. They're great. The career fairs are typically very good. At the career fairs, I think you'll find some companies are more interested than others, and don't waste your time with the companies that don't seem interested. I remember when I interviewed, Ford was just kind of like eyes glazed over, and they were telling you to apply online after talking to the guy for a couple minutes, and that was kind of disheartening. I was like, wow, that was really sort of not interactive. And then I went over to GM, and GM was like, oh, great, and like they talked to me, and then they were like, would you like to sign up for an on-site interview, like for an interview on campus? I was like, when is it? And they said tomorrow. And it's like, oh, okay. Like, you guys are much more interested in actually talking to students outside of a career fair and getting them started on the hiring process. And that was much more interesting for me, and it ended up working out. And I got my first job offer from GM by going to a career fair and having that initial talk and, hey, would you like to sign up for an on-campus interview? Whereas I could have spent half an hour talking to the guy at Ford and gotten nowhere with it. So definitely value your own time at the career fair and find the companies that do seem to be interested. And then another way that I found was good for looking for jobs, especially because I was looking at the energy storage industry, was find an exposition for that industry. So like computers have all sorts of expos. Pretty much every mechanical engineering field has an expo at some point. Where a bunch of industry companies come together and meet at a conference hall or a conference center and sort of showcase their products. And it serves two purposes. One, customers in that field come to these expos and look at all the different types of products available. And then two, the companies themselves scope out the competition. And I found that was really valuable. And that's where I met Tesla and ended up, by meeting the guy at Tesla and getting his business card, got a job offer from Tesla by meeting them at an exposition. And then your personal network, friends of friends are always good, and alumni. I've got a class of 2015 up here. That's us. We're certainly a good resource. I think you have an alumni directory? LinkedIn, cool, got it. So you can find MEng alumni on LinkedIn, and we're a good resource too. Anything to add? So I'll finish with our advice. This is something else I wanted to bring up, is stay stay available or stay open to unexpected opportunities. I was on a plane and ended up talking to someone about his field and his career, and he was in mechanical engineering in the renewable energy industry, which is what I was studying. And at the end of the plane ride, he's like, "So what are you doing after you graduate?" I was like, "I don't know." And he's like, "Well, if you want an interview, call me up." So that's it's one of those things that's totally random, but just met this guy on a plane, and that could have been a potential job had I followed it up. So that's something just to stay aware of. It's like people everywhere, especially in the Bay, are looking for smart, engaging, interesting people. And if you show that you're engaging and interesting, you'd be surprised what shows up.
So one point I want to add on here is that go to as many interviews as you can to gain experience. I know that a lot of international students require sponsorship, and some of the companies will, be very specific and say like we do not sponsor. But I would recommend everyone to go to those interviews because you can get a lot more experience and practice, just gathering data points on how a technical interview is going to be and how you do in those questions. And once you score one company that you like, a job that you like, and it will sponsor, you won't have a problem with interviewing with them. So that's my advice. I went to every single one that I was invited to.
So I've got some other pointers on the slide, but that was the big one that I wanted to hit on. And in terms of starting the job search, I would say start now. Don't stress yourself out about it now, because obviously you have a year of school ahead of you. But you never know when an opportunity will show up that you're interested in. So don't be not looking for jobs. Sort of just keep your eyes, keep your ears open, and I think that's all. Oh, sorry. Thank you very much. Any questions?
I know we're over time, but for people that can stay, I'm more than happy to.
This is my question for Portia for you. So how did you get your job?
I got my job in the Just-in-Time Career Fair, and I started off as an intern. And so basically in our company, an intern is just like a training period, and then I got a full-time offer after that. Yeah.
I'm going to stay here on front for a bit.
Yeah, so if you're afraid to ask questions in public, you can come to me.